Hello everyone, let's solve Leetcode problem number 104, maximum depth of a binary tree. So what the question says, given the root of the binary tree, root is nothing but the first one, first node, this one 3, return its maximum depth. So in this case we can see the maximum depth, it can be either this one or this one, right? So maximum depth is this one. So a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. This is nothing but the parent root. These are the leaf nodes, right? Parent node and the leaf node. Nothing but the parent node is also known as the root. These are all this one, leaf nodes, right? Then what we'll do, how can we do this? Basically, here root is given 3, 9, 20. Here we don't have anything, so they have given null. Finally 15 and 7. The maximum depth, we can visualize this one and we can say the maximum depth is 3, right? So what we can do, initially I'll just come here, just give me a second. So let's consider this example. We have 1, 2, 3 and finally this is 4. Okay. So how can we find the maximum depth? What we'll do, initially we will check whether root is null. If root itself is null, we will be displaying will return 0. So we cannot have the leaf nodes, right? If it doesn't have the root. So that is one thing. So next edge case is, suppose we are if we are having the root and we are having the leaf nodes, what we'll do, we will recursively calculate the depth of the left subtree. Nothing but we will assign the root dot left. Basically, we will make use of the recursive function max depth and we will assign it to root dot left. So here it starts from 0 basically. The indexing starts from 0 in the binary tree. So in this case it will be 1, right? 0, 1 left, and we will assign the we will recursively calculate the depth of the right subtree as well. We will just assign this one to the root dot right for the right this one right nodes. So in this case it is for the left it will be 0, 1, 1, right? In this case right side we will get 0, 1, 2. So this one is 2. Finally, how can we find the max? So we can make use of the math.max of left and right basically, right? Left and the right, and we have to add +1 to it, right? Basically the indexing starts from 0. So suppose if it make use of max of math.max, we can make use of in JavaScript 1 and 2 plus 1, because the indexing starts from 0 as I've said. Here the max is 2, basically 2 plus 1, nothing but 3. That's what we have got here, right? 3 basically. Yeah, this is it. Let's start writing the code. Initially what we'll do, we'll go with the base case, nothing but if the node is null, we will be returning 0 as I have said. So in my case, if root is null, so we'll return null. I'll just give it triple equals itself in this case. This is one thing. Next thing, let's recursively calculate the depth of the left subtree. In my case, I'll just give the variable name left depth and I'll just copy this one. We are recursively calculating the depth of the left subtree, right? I'll just mention the function name root dot left as I've showed in the example, right? So also let's recursively calculate the depth of the right subtree as well. So I'll just copy the same thing and let me make the necessary changes. So here instead of left, I'll just give right. Here instead of left, I'll just give right. This is fine. Finally, as I have said, let's make use of math.max, right? To find the maximum between the maximum of left depth and write depth. I'll just copy this one. Let me copy this one and paste it over here. Next one of write depth. So also +1. Why +1? I had clearly mentioned that the indexing starts from 0. So that here in this case you can visualize that the maximum depth we have got is 0, 1, 2. So the indexing starts from 0, right? That's why we are doing +1 here. It will be 1, 2, 3. So that's what we have got the output basically. So I'll just add +1 and let's hit the submit. So this works correctly, right? So what is the time what is the time complexity and space complexity? So the time complexity would be big O of n. Why the time complexity is is big O of n? The function visits every node exactly once, right? That is the reason time complexity is big O of n. And the space complexity would be big O of h. Why the space complexity is big O of h? Due to the recursion stack. We are clearly making use of the recursion, right? Recursive functions here. So the space complexity would be big O of h, where h is the height of the tree. So I'll just come here and mention time complexity is big O of n and space complexity would be big O of h, and just change this one to C. So yeah, let me comment this one just for my reference. Yeah, this is it. Thanks for watching, guys.